5 times x minus 5, and we FOIL it. Remember FOIL. This is multiplying a polynomial. Here's how we multiply polynomials, so Caitlin and AJ. If I have x plus 5 times x minus 5, it's related to the distributive property. You know how to distribute something like a 3, right? Well, with this, we distribute the x into both things, and then we distribute the 5 into both things. And we use a little shortcut. We call it FOIL, first, outer, inner, last. Okay, so first terms were the x times x. The outer terms were the x times negative 5. The inner terms were the 5 times x, and the last was 5 times negative 5. So we call that FOIL. Okay, all it is distributing twice. So the first thing we do is we take the x times x, and we get x squared. We take the x times negative 5, and we get negative 5x. Then we also distribute the 5. So 5 times x is 5x, and 5 times negative 5 is negative 25. So if I FOIL that out, do you guys see that we have x squared, negative 5x and positive 5x go away, and we get minus 25. Do you all see that? Okay, that is what we call the difference of two squares. So when you have something like x squared minus 25, there's a pattern. We first recognize, oh, 49x squared. 49x squared is what times itself? 49 was what times what? 7 times 7, right? X squared is x times x. So I set it up, and I say, oh, I'm going to need 7x and 7x. So when I multiply my first terms, 7x times 7x, I get 49x squared. Max, Sarkis, you with me? Right. What about the last terms? The last terms need to multiply to be 81. And not just 81, but negative 81. 9 and 9, right? So I put my 9 and my 9 in those spots. But when I FOIL things out, I need for my outer and my inner swoops to go away, just like they did up here, right? The negative 5x and the positive 5x totally went away.
Can you slow down a little bit?
So if the negative 5x and 5x totally go away, see how they canceled and made 0x? That's what we want. We want them to cancel. So in order to do that, we're going to need a plus and we need a minus. Okay, let's FOIL it out and check. So let's do the double distributive property, right? So we're going to take the 7x times 7x. What do we get when we do that? We get 49x squared. That was our first term, right? First. Outer, our outer terms are here. So 7x times negative 9. Not 81. Negative 63x. Not there yet. All right, and then I have 9 times 7x. I see. So 9 times 7x is plus 63x. And then that was our inner. And then our last term's 9 times negative 9. So AJ, it was negative 81. Do you see how the negative 63 and the positive 63 cancel out? That's how we're getting 49x squared minus 81. That's what we wanted. Okay, so we're doing the opposite of FOIL. We're breaking it apart into the two sets of parentheses. So our answer for this was 7x plus 9 times 7x minus 9. Easy enough?
Wait, so how did you get that? How did you know to start out with that 7x before you did
Because 7x times 7x is what's giving me the 49x squared. Okay, is the next one, is it the difference? Shh, guys, difference. Is there a minus sign? Difference. Is there a difference? Yes, difference of two squares. 25x squared, is it something times itself? Yeah, 5x times 5x, right? 16, something times itself.
4.
Yeah, 4 times 4. So this is set up so it's the difference two squares. So we automatically know how to factor that. We write our two parentheses down, and the two parentheses look almost identical, but one's going to have a plus and one's going to have a minus. So what is going to go inside those parentheses?
5x plus 4, and the other one's going to be 5x minus 4.
Exactly, 5x plus 4 times 5x minus 4. Done.
Wait, 5, 4.
Because 4 times 4 is what gives the 16. Yep, you see it. And you can check. Do you guys want me to show you the FOIL step? So if I FOIL this out, my first terms make 25x squared because it was 5x times 5x. Guys, look up here. The outer is 5x times negative 4. That makes negative 20x. The inner is plus 20x. And the last is minus 16. Those negative 20 and 20 cancel, and we're left with 25x squared minus 16. Yes, Caitlin? That's the answer, yeah. It's easy. You got it. We got this. That's the answer. And this one, this is the answer. Right? Not anytime soon. All right, next up. So x squared plus 4, is it the difference of two squares? No, why? It's the sum, right? And try as you might, the sum of two squares does not factor. What do we call numbers that don't have factors besides itself and 1? Prime. So we write prime.
So then we just leave it as that?
Mm-hmm.
So
Okay, so let's guess.
Anything addition?
Nah, not anything addition. The sum of two squares. The sum of two squares does not factor. All right, now try this on your whiteboard. What are your guesses? What do you guys think? Like, if it was going to factor, I would think it's x plus 2 times x plus 2. Wouldn't you guys think x plus 2 times x plus 2 works? Yeah, go ahead and try x plus 2 times x plus 2 on your whiteboard and do the thing where we multiply the x into both things, right? And then you multiply the 2 into both things.
Wouldn't it be x plus 2 times x minus 2?
Well, you can try that one as well. So try both. So try x plus 2 times x plus 2 and try x plus 2 times x minus 2. Will, you got it? AJ, this is what you missed, so pay attention. So if you're doing x plus 2 times x plus 2, we're going to take the x, and we multiply it into both things here. We distribute it into both. And then we take the 2, and we distribute it into both. And we combine any like terms that we have. So when we do this, we get x squared. Did anybody find it? You should have plus 2x plus another 2x plus 4. So we end up getting x squared plus 4x plus 4. That doesn't make x squared plus 4, right? So what was wrong with x plus 2 times x plus 2? We had that middle term. We had an x term. They didn't go away. Now if you try x plus 2 times x minus 2, those middle terms will go away, right? So we would get x squared minus 2x plus 2x minus 4. Did you guys get that? So those middle terms do go away. But what's wrong with this? Why is it not x squared plus 4? There are not too many x's. It's negative 4, right? It's not positive 4. We had a positive 2 times a negative 2, and we got negative 4. We didn't get positive 4. Okay, so that is why the sum of two squares is prime. Because try as you might, it will not factor. All right, so this next one involves both things that we've learned so far. So first, do you see that there is a GCF? We always look for GCFs first. That's the first thing we learn with factoring. What do they both have in common? They have a 5. How about x's and y's? Anything? Do we have an x in common? No. Do we have y's in common? Yeah. So we have a 5y. So our GCF equals 5y. So we're going to pull out the 5y. And when we do, we have x squared minus, 5 times what gives 125? 25. Now this is now the difference of two squares. So just like with numbers, you know, numbers, sometimes you try to factor it and you're like, oh, but now this number goes further, right? This goes further. So we continue to factor it. Okay, so the 5y stays out front. And how does x squared minus 25 factor? Who's got this down? Who has it? Ryan, do you have it down?
No.
X squared minus 25, it's the difference of two squares. Sarkis, what do we think?
No. I was wondering on number 4. Should the 5, like, where did you do, like, why is the 5 still a 5? Or, oh, wait, no,
The 5y, why is it still up front?
Is it because you're factoring it into?
I'm trying to factor it. It's like I'm doing a giant factor tree. And so I pulled that out, and it continues to drop down, drop down, drop down. Yeah.
Is it x plus 5 and x minus 5?
It is x plus 5 times x minus 5. Perfect. Do you guys see? And that is the final factored form. Done. All right, and then the last method we're going to learn today is called factor by grouping. All right, the way that you can tell you're going to factor by grouping, Will, you with me? Is if you have 4 terms, or 6 terms, or 8 terms. So if you have an even number of terms, okay? Besides 2, it gets 2, look for the difference 2 squares. Usually in Algebra 1, it's going to have 4 terms, okay? So we have 4 terms here. And I always call this split the middle. So factor by grouping, I always say split the middle. So what are we going to do? We're going to split it right down the middle. And I'm going to go right in front of that sign there. So I went right in front of the plus. And I'm going to ignore that 2x minus 12 right now. So don't cross it out, but I'm going to kind of say, okay, I'm ignoring that part right now. Then I do the Gcf method. So with x cubed minus 6x squared, what do I have in common? What's the GCF? It's x squared, right? 2 of the x's. So I pull out an x squared. So I'm going to have x squared. what will I need inside the parenthesis when I pull out that x squared? X minus 6. Do we all see that? So if you multiplied x squared back in, you would have x cubed minus 6x squared.
I don't see how you get the
6x squared.
X minus 6.
Because if you multiply this x squared back in, you get x cubed, right? And x squared times negative 6 gives negative 6x squared. All right, if you do factor by grouping correctly, you will always, whatever you had in parentheses right here, you'll have over here. Is there a magical number that I can pull out to have x minus 6 left? A 2. Do you guys see it? Basically, you're saying, what's the GCF over here now? Right, I have 2x minus 12. What's the GCF? It's 2. And when you pull out a 2, you have x minus 6 left. Okay, I always say pull out a number and a sign. So not only just 2, I'm going to pull out a positive 2, right? Plus 2. All right, so here's the weird part. Now this whole thing has a GCF. It has something in common that we can pull to the front. I've underlined them with my little squiggly lines. Do you see that they both have this common factor of x minus 6? Right? So x minus 6 is now a GCF. So what do we do with GCFs? We pull them to the front. So we're going to pull out that x minus 6. And when we do, the thing that's left is x squared plus 2. And we write that inside of parentheses. So we write x squared plus 2. That is our factored form. Done. How do I know x squared plus 2 doesn't go any further? Is it the difference of 2 squares? No, not a difference because there's a plus, and 2 isn't even a square. So I'm done. But we always look for things like that. All right, I'm going to send you on a break really quickly.
Wait, this is cross one
All right, so sometimes, oh, what do you mean, Sarkis? Sometimes you have a combination of factoring. So like we did the one where we had the GCF, right? And then we did the one where, so once we pulled the GCF, then we had the difference of 2 squares. This is similar to that. So we're going to do our factor by grouping. But once we do our factor by grouping, maybe it goes further. So we're going to look and see if it goes further. All right, so here we go. So we're going to split the middle. So always go in front of that sign right there. So I have x cubed minus x squared. And if I have x cubed minus x squared, I want to know what they have in common. They have x squared in common, right? So I'm going to have inside x minus 1. Do we all see how I got the x squared and then x minus 1? Imagine multiplying it back in. Right, you'd have x cubed minus x squared. So you're dividing by x squared for each one. Okay, so the next one, I have negative 25x plus 25. And I told you, I said, if you do factor by grouping correctly, the parenthesis part's going to be the same. So a lot of times I just have my students write that x minus 1 down, and then they think, okay, what do I need in order to have negative 25x plus 25? What number and sign is out front? So looking right here, if I have negative 25x plus 25, 5 squared, which is 25, right? So it's going to be minus 25. Do you guys see how when you have negative 25 times x, I get negative 25x. Negative 25 times negative 1 gives me plus 25. Do you see that? Oops. All right, now I have a GCF. The thing I have in common now is x minus 1. So with GCFs, I pull GCFs to the front. And I write x squared minus 25 in parentheses. All right, Xavier, what do you think with x squared minus 25? It's what? X minus 5 times x plus 5, right? Because now this is the difference of 2 squares. And then we're done. Okay, so we have it fully factored. All right, so you're going to have something like that on your homework where you have to keep going until it's all the way down.
How do you know when you get all the way done?
Usually it's like x to the first, and there's no GCF in any of those parentheses. See how you have like x minus 1, there's nothing you can pull out. X minus 5, nothing you can pull out. And then if it had something that says like x squared, always look for that difference 2 squares. But since these are x to the first, it doesn't go down any further. All right?
Still confused, but okay.
All right, so let's try this one. So we'll do one more where it keeps going, and then I'll have you do the next one as well. All right, so I have 4x cubed plus x squared minus 4x minus 1. So we split the middle. All right, so I pull out the GCF. I pull out an x squared. When I do that, think about what you have in parentheses. So if I had 4x cubed and I divided by x squared, what's left? 4x, right? So I need a 4x. If I take the x squared and I divide by x squared, what's left? X squared over x squared is 1. A lot of people will forget that 1, but you need it. You guys see how if you multiply back in, x squared times 4x gives us the
What
4x
one?
cubed.
Where do you get
This one right here.
I know, but where do you get
If I'm multiplying back in, check. If I take the x squared in, x squared times 4x is 4x cubed. X squared times 1 gives me the x squared. I need that 1, otherwise I don't have the x squared, right? All right, so over here, I know if I do it correctly, I'm going to pull something out, and I'm going to have 4x plus 1 left. Yep, do you guys see that it's negative 1? If you have a negative 1 and we multiply it back in to check, we have negative 4x minus 1. That's what we wanted. So now we have our GCF of 4x plus 1. So we pull that 4x plus 1 all the way to the front, and we're left with x squared minus 1. Since it's an x squared, we say, oh, well, does this go further? Is this the difference of 2 squares? Caitlin, you with me?
X squared, yeah.
If it's x squared and it's minus something that's a perfect square, right? So see how that's a difference? There's a minus in between. And x squared is x times x. And 1, is that something times itself? It is, right? 1 is what times what? 1 times 1, right? 1 times 1 gives you 1. So it's still the difference of 2 squares. So it still goes down further. So it breaks into x plus 1 times x minus 1. And we still have that 4x plus 1 out front. It's just like a factor tree. We just pull down the factors that didn't go any further. All right, if you can do number 4 on your own, you'll be good to go for your homework. Do you want to try it? All right, so try it first. All right, so if I have 8x squared minus 4x minus 2x plus 1, what I was saying is we split it down the middle, so go right in front of that sign, and momentarily we just we ignore this part right here. And we're like, well, what's the GCF if I only had 8x squared minus 4x? So do you guys see what the GCF would be there? The GCF would be 4x, right? For this side. So we're going to pull out a 4x. So I'm going to have a 4x, and then I'm going to have inside parentheses what I need in order to get 8x squared minus 4x. So if I had 8x squared and I divide by 4x, I'm left with 2x. And if I have negative 4x and I divide by 4x, what do I have? Negative 1. Do you guys see that? And you can check, if you multiply back in, 4x times 2x is 8x squared. 4x times negative 1 is negative 4x. Okay, so we have it. Now we focus on the right side of the equation. Okay, so if I'm looking at the right side of the equation, so I'm temporarily kind of ignoring what was over here. So if we ignore that, if you do factor by grouping correctly, this is the part that many of you guys were messing up on. If you do it correctly, the part that's inside parentheses should be identical if it's going to factor by grouping, okay? So go ahead and write that 2x minus 1 down and just say to yourself, well, what do I need in order to get 2x minus 1? What do I have to pull out from here? I need the negative 1, right? It's always a number and a sign. So, like, Tessa did it correctly, and Tessa was like, oh, it's just a negative. And she put the negative, but then, like, she got to the part where she needed to write the 2x minus 1 out front, and she was like, I don't know, do I have, like, 4x negative? Like, so that's why you always have to pull out a number and a sign. So you need a negative 1, okay? So it's going to be 4x minus 1 left, and that's our answer. That's what we write it as. Okay, the reason this works is because you guys know how 4x, let's say I had w, minus 1w. You know how to do the GCF thing there, right? What would the GCF of this be? 4xw minus 1w. What would it be? What do they have in common? What variable? W. And you'd be left with 4x minus 1. That's the same thing that we're doing here. This is kind of like our w. We pull the w to the front, and inside parentheses, we write 4x minus 1. Okay, that's all we're doing. It's exactly the same. So we factor the common factor to the front. All right, so shall we try some problems on your whiteboards? You guys want to try a few more, or are you just ready to try your homework? What do you want to do? Homework?